Okay, so welcome to a video on topic 18. We're going to look at solving linear inequalities. So to begin with, let's make sure we understand what the different symbols mean. Okay, we kind of already did this together a bit, but let's just review it. So this first symbol here is the greater than symbol. So this is the set of all numbers that are greater than 4. But remember, if you don't have the equal to underneath, 4 is not greater than itself. So we're going to put an open dot here. So then for x to be greater than 4, we're going to make it go to the right. Okay. The symbol here is telling us that we want the set of all numbers that are greater than or equal to 4. So that means 4 is now allowed, and so we're going to make a nice solid dot, but we're still going to go to the right. For less than, okay, we have the same situation. First we have all the numbers that are less than 4. We're not including 4 here, so we're going to have an open dot, but this time we're going to go to the left. And the last one is here, less than or equal to. 4. So 4 gets to come to the party again, make a nice solid dot, and we're going to go left. Okay, so I want to talk about some different phrases and stuff that you could use or you could see in word problems that mean these symbols. We know greater than, but we could also use things like more than, larger than. We can do more specific things like taller than, older than. You can get really specific with this, like more expensive than. Okay, I ran out of room, so that's probably good enough. All right, greater than or equal to. There's one specific phrase I want to make sure that you understand, and that is at least. At least means greater than or equal to. So for example, if your mom says you must do your homework for at least 2 hours, and you do your homework for 2 hours exactly, that meets the conditions. If you do it for 2.5 hours, perfect. So anything greater than or equal to 2 hours would be at least. It's like a minimum value. In fact, yeah, that's another good one. A minimum of. It's setting a beginning sort of amount that needs to happen, but if you go above that, it's okay. All right, less than, smaller than, younger than, things like that. Okay, with less than or equal to, there's another phrase that's very similar to at least, but it's the opposite of that. It is at most. Okay, or for a minimum of, we could say a maximum of. So at most means that's the top limit. You can't have any more. Like this classroom can have at most 20 students. Okay. So let's talk about how to solve inequalities. They're very similar to solving equations, but there's some very important differences. So if you look at the second page, you could see the types of problems we're going to be doing. 5x minus 3 is greater than or equal to negative 18. One big difference is it's not an equation. And equations have one solution. Inequalities have a lot of solutions. So you're not solving for one solution. An inequality is a set of solutions. So it's usually an infinite number of solutions. You can't count them, there's so many. So that's why we graph them, to show all the solutions. Okay, the second one is really important, and let me give you a demonstration for what's going to happen. So let's say we have 5 is greater than 2. That's true, right? 5 is greater than 2. What if I multiplied both sides by, I don't know, 4? I would get 20 is greater than 8. Is this still true? Yes, 20 is greater than 8. What if I multiplied by -4? So I'm multiplying by -4 to both sides. I would get -20 and -8. Is this still true? No, negative numbers don't work the same way as positive numbers. The larger the negative number, the smaller it is. So this is false. Unless I change the symbol around, then it's true. So there's this property of inequalities that basically says when you multiply or divide both sides of an inequality by a negative number, you need to switch the inequality sign. So let's say I have this problem here. -2x is less than 10. In order to solve this, I'm going to have to undo what's happening to the x. So I'm going to have to divide by -2. Because I'm dividing by a negative number, I don't get x is less than -5. I get x is greater than -5. So you see how I went and changed this to this? Okay, so where'd my little pen thing go? Okay, so the next thing you need to pay attention to is if you switch sides, you're also going to need to switch the inequality. So what I mean by that is, let's say you have 5 is greater than 2. If you go and make the 2 on the left and the 5 on the right, it's going to be less than now. I guess that's my example. Okay, there's this part here about inequalities with special solutions. Let's just skip that for now. And let's start solving. Okay, so just like with an inequality, you're going to need to follow the same sort of steps. So like first, distribute. If you see anything you need to distribute. Second, combine like terms. Third, get your variables onto the same side. Fourth, undo what is happening. Okay, so in the first one here, we don't have distribution. We don't have like terms to combine. We don't have variables on the same side, so we just need to get to solving for x. So I'm subtracting 3, so I'm going to add 3, just like I do in an equation. Bring down the 5x, bring down the greater than or equal to, and bring down the -15. It's going to be very important that you don't accidentally switch sides at any point, because that inequality is going to have to switch. So try to keep everything on the sides that they're on. Okay, now I'm going to divide by 5. Now I'm dividing by a positive number, so I don't need to do any switching. So that gives me x is greater than or equal to -3. Now notice there's a number line here because we have to graph that. Since it's greater than or equal to, I'm going to make a nice solid dot here at -3. And I'm going to go to the right because it's greater than. Number 2, I don't have distribution. I do have like terms I need to combine. So on the left side, I got 2x and a -6x. So I'm going to combine those to get -4x. And I'm going to bring down the +1, less than 17. Then I'm going to undo what's happening. So subtract 1, cancel. Now I need to divide by -4. I am dividing by a negative number, which means my inequality sign is going to change from less than to greater than. Okay, so here that -4's cancel. 16 divided by -4 is also -4. Okay, so I'm going to make a nice big open dot at -4. It's open because it's not equal to, and it's greater than, so I'm going to go to the right. Okay, and we're done with that one. Okay, number 3 is a little bit more complicated here. Notice we have some parentheses, so we need to distribute first. So that would be 9x, and then we're going to make that -6x plus 14. And the rest of it stays the same. Okay, now we need to combine like terms. I see I have 9x minus 6x. Those are going to turn into 3x plus 14. Everything else stays the same. Notice I have x's on both sides. So I need to subtract, let's subtract 3x from both sides. Uh-oh, do you see what's going to happen? The x's here are going to cancel, but they're also going to cancel here. So that gives us that 14 is less than or equal to 10. But is it? Is that true? No, that's not even close to true. This is a big false statement, which means there is no solution to this. So this is one of the special ones. So I'm going to go back up to these notes we skipped. Sometimes when solving an inequality, you get a statement that is never true, such as, we'll use 14 is less than 10. Is that what it was? Less than or equal to 10. So the solution to these types of inequalities is, well, there's no solution. If something similar happens, but it turns out that it's not false, but it is true, such that it is always true, okay, such as, I don't know, 14 is greater than 10, that's true all the time, then these inequalities have infinitely many solutions. In other words, there's no wrong answer. We didn't get an example of that one. Well, I don't know. Let's try example 4. Okay, why don't you pause the video and try example 4 and then unpause it when you're done. Oh, excuse me. Okay, pause the video, try example 4, and then unpause it to see if you got it right. Okay. Did you get a decimal? Then you probably got it right. So we distribute the -2. We get -2x plus 8 minus 1 is greater than or equal to 7x minus 5. 8 minus 1 can be combined to give you 7, so this can be combined. So then I added 2x to both sides. You could have also subtracted 7x. So if you subtracted 7x from both sides, your answer will still be the same, but it might be a little different looking. Okay, then I moved it up here just for more room. Then I added 5 for both sides. And now I'm dividing both sides by 9. 12 divided by 9 is 1 1/3 or 1.333. Because I divided by a positive, I didn't need to switch the sign. If you did the subtracting of 7x, you'll probably end up with a negative that you have to divide, and then you'll have to switch the sign. Now, my answer over here is not written like I'm used to seeing it. I'm used to seeing the x in the on the left. So I can put the x on the left and the 1.3 on the right, except I have to switch this sign. Okay, so to graph this one, I'm going to put in, find 1.3, which is like somewhere around here. Put a nice solid dot, and I'm going to go less than. And there we go. That's the end. Okay, work on your lessons pages for this week. Okay. All right, that's the end.